Hello everyone, welcome to my channel, and today we will be talking about capacitors. For those who've been following my channel for years, you know that I did multiple experiments, like hundreds of experiments, using different capacitors, trying to understand how they shape the sound. And all of them shape sound differently. And the biggest problem I discovered with electrolytic capacitors that more capacitors we have, the more information loss we obtain as results. Like for example, in cassette decks, in average on the sound path between record and playback chain, we have about 20 capacitors. Minimum was like 10 per channel, average is 20 per channel, right? Some decks employ even more capacitors. And doing analysis of different sound shape change, I was thinking like what can affect, and my mind over time was changing either, right? So I thought like it's capacitors, right? So it just should be new, should be of a good quality, of a known brand. And when I replaced these old guys, right? I just like enjoyed. Okay, I have now more full sound, right? It's more rich, like it's better in the low range. It's better dynamics because capacitors are fresh. Excuse me. And then I started to experiment with different technologies. If you remember this Wurst electronics, solid polymer, this Chemet solid polymer, and sound was different. It was very crisp and detailed on the high frequencies, and very extended in the low bass area. Like the range of the cassette deck started to shape and change differently. But what has been lost the warmness, like in the vocal range. Like they didn't sound that natural, right? They sound really crisp, very clear, but not that natural. Oh yeah. Then like I started experiment with these film capacitors because first of all I've seen some mods which use these capacitors, but I didn't think that I want to replace small capacitors whenever. And if you remember, I started from the small values. I was modding the Nakamichi Dragon, Nakamichi RX505, because those use it like 1 to 2 microfarad VMOS, like electrolytes, which I would can easily replace with VMOS, right? And it did work. The sound shaped, and like the biggest change was like that the drum hats particularly did sound like the way how I remember them, because I spent like 7 years on stage, so I know how drums should sound, right? And I have really specific listening, like when I hear each instrument, even if there is a big band is playing, I hear each instrument separately. That you cannot train like just listening to the stereo system. And that was really interesting because hats, if you know, there is two patterns which has been shaped on the hats. One is like kind of crisscross, which gives small caveats and like dissipates sound one way, and other is like circular rings, which are stamped on the hats. And when like you use these hats, you hear those different rings produce like a set of frequencies. So like those are not mixed together; those are separate frequencies correspond to the rings. And that was the biggest observation. Like what I have heard It's bring very natural form of the sound. That makes me think like what's makes it different. I continue experiments. I bought these large capacitors, even bigger, install it in the couple decks if you remember. And this really improved the sound to the point when like it became like really close to the source, right? When you switch in between digital source on the amplifier and the cassette deck, the sound differences specifically on Sony KS7 is abysmal, right? I started to think what would be the root cause of this problem, like, and what can introduce that differences. I did research. I spent hours with ChatGPT trying to find explanation. It's a dumb machine. Don't get me wrong, but sometimes it can provide you with information which makes you think different way, and you can go and discover something else. And there was couple issues which has been highlighted with electrolytic capacitors, and why I'm currently bypassing them with VMOS. I will tell you more. The issue number one, which we will validate right now with like LC meter. I've got this really nice LC meter. Right. The issue number one is non-linear response depending on the frequency, and I'm ready to demonstrate. Let's get like this Nichicon Fine Gold, really good capacitor. I really like how the sound. Okay, it's 10 microfarad, and currently I'm measuring at the 100 Gz, and you may see 9.9 microfarad, really good results. And now it's fresh, a brand new capacitor, recently manufactured, right? I'm changing frequency 120 Gz, you see, and it still shows very low ESR. No, let get me to ESR. Q is phase ESR 2.8 ohm. It's still pretty low at this frequency, but take a look. We are at 9.88, 1 kilohertz, 9.55, and ESR dropped. 10 kilohertz, 9.2, and ESR dropped more. 100 kilohertz, 8.4, and ESR dropped even more, right? So what you observed just 10% difference on the capacitance, right? Based on the frequency response. So the best capacitors, brand new, gives like around 5%, specifically in the sonic range, about 5% deviation. But what happens with the older capacitors, you wouldn't believe me, it gets like to 50% deviation. Let's test this one. Okay, 100 Hz, 10.7 microfarad, 18 ohm. Wow, ESR is huge already, right? 120 Hz, not a big change, 1 kilohertz, 9.4. We just dropped 10% between 100 Hz and 1 kilohertz, and ESR changes triple times, even more. 10 kilohertz, we have just 7.8 microfarad, 3.9 ohm. Still very big ESR. And 100 kilohertz is just 1 microfarad. So that's how old capacitors shape the sound in your decks. And don't tell me like that I'm like just like killed original sound. No, like every deck, as I remember, in 1980s, they've been trying to do as best as close to the original sound as possible to make them reproduce. The only difference, they've been shaping a little bit to the make company sound, all right? And company sound, like they played a little bit with timing, like for example, do not 120 microseconds, but 111 or 130. And like this really changes the patterns how decks sound. What's next? Remember these capacitors. Let's do this. 10 microfarad as well, right? Polar. So shorter is a minus, longer is a plus. 100 gears, it has just 2 ohm, right? 11 microfarad. 120, 11 microfarad. One is 1.7 ohm. 1000, it's still 11, but it's 0.4. 10 kilogears is 10.3, but ESR is super low, right? And 100 kilogears, capacitance increases, but ESR is very, very low. All right, so that capacitors are better than electrolytes in many cases. Not for sound, for sure, but for power supplies, like these are way better than electrolytes due to way lower ESRs, right? We also need to read about ripple currents. So for power designs, like there is, we need to consider more parameters than just ESR, okay? What next? Bipolar, Muse. Sounds really good, but the problem that they eat high frequencies. Take a look, 10.4 at 4 ohm ESR, 120 gears, 10.4, 1 kilogears, 10.1, ESR is good, 10 kilogears, 9.8. Well, you see, like, new capacitors has way better parameters than the old ones, right? Even 100 kilogears is still 9.8 with low ESR. That's how good these capacitors are, okay? So, what changing? Now, when we switch to the film capacitors, the biggest change we get that there is like very minimal response to the frequencies. What's happening? Like, you see it's 9.2, but it's already 0.3 ohm ESR at 100 Hz. 120, 9.2. 1 kilohertz, 9.1 ESR super low. 10 kilohertz, 9.1. You see, there is no dependency from the frequency. And that's a biggest change in technology, like, right? It's when it shaped sound, it would not produce THD. So we love these guys for THD, really, because like those 5-10% on frequency change introduce THD. These guys don't introduce THD. But this would be the half of the problem, right? Because like dependency on the frequency is the smallest evil electrolytic capacitors do for the sound. There appear to be a pretty interesting effects. Like everyone like knows about it, but for some reason no one accounts it in audio. And it's called memory effect. When electrolytes cannot quickly discharge, specifically when there is like high level signal, right? And there are small level signals, and they try to pass through, but they cannot because electrolyte, it's liquid, don't give them ability to quickly discharge, and this discharge is delayed because of this memory effect. And what it does for the sound, what happens that transients, those like small level signals, being delayed. And what I learned with my last two changes, like when I bypassed electrolytes in my ducts, that these delays very significantly affect how we hear the imaging from the music and the stage itself. When I upgraded my Tascam, it becomes super precise on the stage. It was so pleasant to hear when each instrument just separates in space, right? And when I switched it back to live audio DAC, the imaging was blurry. like you cannot identify. Like you hear that it's white, but you have a hard time identify from what direction sound is coming, and that did bother me. Like really, I wrote email to live audio, got response, wrote another one, got response, wrote another one. We've been discussing what can be affecting this diffused image, because like when I looked into design, I see like from the top of the board that they have audio node capacitors, and they have VMOS like close to it. Like I thought like maybe they do bypass, but they did not. And that was they responded me at the end. My audiophile friend, he used a different approach. He tried to fix imaging in the digital domain. He introduced like DC to digital converter, like live DDC, and he didn't fix the problem. And he also used random box, and with random box and DDC box and then DAC, he told me like the imaging significantly improved. But looking into the DACs, I see that there is a CPU, STM32 is really powerful 32 bits CPU, which technically should receive data from USB bus, align in time, and send properly to the ladder to timely reproduce it. And that's what happened. Like I did not believe that the problem lies in the digital domain. And I did my experiment, and if you already seen my video, I've upgraded the live audio DAC as well by introducing bypass capacitors. So what happens? So let me get the small one, just a second. So I use just like small MKP series, MKP4 10 nanofarad. And when we use these two in a parallel, what would happen? I will try to reproduce, I will just try to wound these legs around. I would not solder, just wound around. Okay? And another one here. What would happen? Can you guess? I know what I hear, but let's measure. So capacitance didn't change. Let's switch to 100 Hz. You see, ESR didn't change significantly, right? 10.5. 120 Hz, no change. 1 kilohertz, no significant change, right? 10 kilohertz, again, like there is no big change. None in the values, none in the ESR. But what changed the timing. So when small signals, they have now a new pass, right? The high frequency small signals just use VMA to go through, when large level and low frequency signals go over the electrolyte. So they just have shortcuts. This restores the timing and proper phase on the DAC, and then like your imaging is improved right away. There is no change in the shape of the sound. There is no change in the sonics. DAC doesn't sound harsh. Like absolutely nothing changes from sonic perspective. The only change is in imaging, when like from blurry fuzzy imaging, when you cannot tell like where is instruments located, and when if you hear the image is wide but you cannot tell, you get to the pinpoint location of every drum, every instrument, every vocal, and stage becomes very wide, but at the same time like you can tell where they are. It's really interesting experience, and it's really great to hear it. Really, it's a super nice experience, and I would highly recommend you to try. Also, if you don't trust me still, right, you may find a video of Paul McGowan from PS Audio when he says that now they bypass all electrolytes, absolutely, including in their DAC, in their amplifiers. They just use like 100,000 picofarad. I'm used 10,000 picofarad or 10 nanofarad, right? And the main point is to restore phase and restore this like timing and clarity and make sure that everything will be aligned properly. I can understand we cannot use or don't want to use these large capacitors, even if this would be the best solution, because they are expensive, they are big, take lots of space, and additionally, this is 10 microfarad. My friend got 100 microfarads, those the size of a fist. And there is another problem will start rising is inductance. So let me switch to inductance. If I can measure it here. Let's try it. Okay. Inductance of this capacitor pair is 202 millihenry. 242. Okay. But the more layers you have, the bigger inductance should go. 274. Okay. Let's try solid polymer. $222 millihenry. Okay. Which one? $255. All right. You see, like the bigger the cap, the bigger inductance, and this will shape sound easier. So don't get me wrong. Capacitors matter. My research shows that this would be the best option, like use film caps in a parallel. This would be the cheapest, but at the same time super efficient option to build properly shaped and timely sound. I did a couple more experiments yesterday, right? I also connected my Super Audio CD with coaxial. Definitely I cannot run Super Audio CD over coaxial, but I run regular CDs, and the imaging was like the same, just better, right? So like the details, clarity, locations better from the more expensive DACs than from the Sony, and it's now on pair. Like you can identify from where the sound is coming. It's really great experience. All right, probably that should be it. We spent already lots of time. Now, like a brief part, why replace capacitors. So 100 microfarad, 16 volts, 40-year-old capacitor from Nakamichi 1000 XL. Sorry. It's not that convenient with these big props. All right. What do we have? 100 gears. All right. 96 microfarad. 1.6 ohm. Not bad, right? 120 gears, 96. 1 kilohertz, 90. 10 kilohertz, 70. You see how big is the change? With new capacitors, we learned that it's just below 10%. Here we observe like 30% change in capacitance over the frequency. Yeah, 100 kilohertz is nothing. It's satin. All right, 330. 376. 375. 341. At 10 kilohertz is just 200. So, if you use cheap LC meter, yeah, you see ESR is good. Yeah, capacitance is good, but capacitance on 100 hertz. All right, that is not what we need. Yeah, for power supply probably it's still fine, but for the sound it's not what we need really. Let's do this like 4.7 because these are sit in the sound pass in 1000 XL. So it's 4.9, 4.9, 1 kilohertz 4.5, 10 kilohertz is 4. But ESR, you see, it's still 4 ohm at 10 kilohertz. It's a killer. Okay, you see yourself. First of all, that replacements are needed, and let's stop this Hollywood. I'm like, under each my video I receive, or why you replacing it? I'm tired to answer, so I would not answer these comments anymore. Now you know how capacitors are different, how they differently shape the sound, right? So film capacitors, the closest to the ideal capacitor. Those are definitely don't shape the sound. The main they don't shape the sound, right? They pass all frequencies evenly. They don't change the phase, timing. They don't have memory issues and so on. This one with MKS, right? MKP would be better. I know it, but MKP is technically unobtainium today. So I use MKS here. I was lucky to get MKP, the small ones. I hope this will stop Hollywars. I hope like that it will stop ridiculous comments under my video with live upgrade. So I killed it. I would not like the sound. After 2 days, I will revert back. I would not, because like there is no change in the sonics. Absolutely zero change to the sonics, right? When you do like that. The only change in the proper timing. That's it. When you hear the stage better. When I installed pure VMOS into my Pioneer and my Sony deck, that became super precise decks. They sound really great. Plus, like the losses. Like we need to talk about high frequency losses. You've seen that due to those differences, the sound when it goes like not just through one electrolyte, but if there are like 20 of them, and when sound goes like over 20, it lost little by little, and like at the very end, high frequencies are just not there. And when I measure, it's right, but when the music is playing, like I play white noise or rose noise, which is more relevant to the music spectrum, high frequencies are not there. And with VMA caps, high frequencies are exactly as there should be. Like when you switch in digital source on the amplifier versus deck source in source mode, there is no difference at all. Okay? That's why it is important. All right, it was a long video. I hope you enjoy it. I hope you now better understand what's happening and how capacitor shapes the sound. I thought to come up video with the charts. Let me know if you're still interested. I may come up with some charts we built with ChatGPT when we've been doing analysis of what can affect sound and how it's shaped. But that's probably it. Thanks for being with me, and see you in my next videos. Bye-bye.